Here we have f of x equals x minus 3 times x plus 2 times x plus 5. We want to graph this polynomial function by hand. How do we do that? First, we need to find some important points in the graph, such as the x-intercepts and the y-intercept. Let's start with the x-intercepts, or the zeros of the function. The zeros of the function are the values of x that will make the function equal to 0. So we want to make f of x equal to 0. That's the function. We want to make it equal to 0. So then here we'll have 0 equals x minus 3 times x plus 2 times x plus 5. So we notice that we are multiplying three expressions, three linear binomials, and the product is 0. Well, we're going to get a product of 0 only if one of these factors is equal to 0, or two of them are 0, or all of them are 0. So if at least one of the factors is equal to 0, then the product is equal to 0. Now that idea will help us determine the values of x that will make f of x equal to 0. So we'll say here that one of these guys have to be 0. So maybe it is x minus 3 that is equal to 0. If not, then it is x plus 2 that is equal to 0. Or both of them, both of x minus 3 and x plus 2 are 0. If not, it is x plus 5 that is equal to 0. All right, so now we are going to solve for x in each of these equations. So we want to isolate the x on the left side. So here we're going to add 3 to both sides so that x is equal to 3. So we're saying that this is a possible 0 of f of x. Now let's find out. If I plug in 3 into x, this becomes 3 minus 3. And 3 minus 3 gives me 0. 0 times whatever these two numbers are, that's going to give me a product of 0. Therefore, we say x is a 0 of f of x. Okay, let's move on to the next factor. Here we want to isolate the x, so minus 2 minus 2. Therefore, we'll have x equals negative 2. Is negative 2 a 0 of f of x? Let's double check. If x is negative 2, then negative 2 minus 3 is going to give me negative 5. But if I have here negative 2 plus 2, that's going to give me 0. Times whatever this number is, I know that the product of this whole thing will be 0. So therefore, we say that x is a 0, or rather, x equals negative 2 is a 0 of f of x. Now, the last factor, x plus 5 equals 0, so we subtract 5 from both sides. We'll have here x equals negative 5. Now, is negative 5 a 0 of f of x? Let's double check. So if we have here negative 5 minus 3, that's going to be negative 8. Negative 5 plus 2, that's going to be negative 3. But negative 5 plus 5 is equal to 0. So when we multiply these three numbers, we know that the result is 0. Therefore, negative 5 is a 0 of f of x. So we notice that f of x has 3 zeros. Did you notice that f of x also has 3 factors? Three linear factors. And there are 3 zeros. Now these zeros are the x-intercepts. So now we know that the graph will go through the following points, which we call the x-intercepts. It will go through 3, 0, -2, 0, and -5, 0. Now we need to find the y-intercepts. Now the y-intercept is the value of y when x is 0. In other words, the value of y is the value of f of x, okay, when the value of x is 0. So y-intercept is f of 0. So to find f of 0, we are going to use f of x and change x to 0. So x minus 3 becomes 0 minus 3. X plus 2 becomes 0 plus 2. And x plus 5 becomes 0 plus 5. Then we simplify each of these expressions. We'll have 0 minus 3 is -3. 0 plus 2 is 2. And 0 plus 5 is 5. So now we need to just multiply these three numbers. -3 times 2 is -6 times 5 is -30. This is the y-intercept. So this gives us another point, which is, let's put it here, this is the y-intercept. And when x is 0, y is -30. So far we have 1, 2, 3, 4 points in the graph. So we just want to see how the graph behaves around these 4 points. So to do that, we need to draw a line. So let's draw the x-axis. So we're going to put the x-axis right here. Okay, this is the x-axis. Therefore, we're going to put the x-intercepts in the x-axis. Okay, so the x-intercepts are 3, 0, or just 3, -2, and -5. Now we have to arrange this from lowest to highest, from left to right. So -5, we can put -5 right here. And -2 maybe here. And 3 here. Notice that we don't really try to find their exact location on the number line. We are just arranging them on the number line, not in order, like from lowest to highest. So what happened to the line when we put these x-intercepts on the line? We notice that the line is divided into 1, 2, 3, 4 sections. Now each of these sections is called, we can call it an interval. So this interval is from -infinity to -5. This interval is from -5 to -2, and then the interval -2 to 3, and the last one is from 3 to +infinity. Now what we want to know is, where is the graph in these sections or in these intervals? Is it above the x-axis or below the x-axis? Now, how can we find out if the graph is above the x-axis or below the x-axis in each of these intervals? What will tell us that? Well, if we have a coordinate system here, say that's the x-axis, and this is the y-axis. We should we should know that when y is positive, then y is above the x-axis, and when y is negative, then it is below the x-axis. So if we can find the sign of f of x in each of these intervals, then we know where the graph is in terms of the x-axis. We will know if it's above the x-axis or below the x-axis. So how do we do that? First, we need to find a number in each of the intervals that we are going to use to plug into the equation. So let's say here in this interval, I know that -6 can be found in this interval because -5, then to the left is -6, then -7, -8, -9. We can choose any number here, but for convenience, let's use x equals -6. And in this interval, what can we use? We can use x equals, we can use -3 or -4. So let's pick -3. And in the interval -2 to 3, we can use 0. I like using 0 because it's easy to perform operations with 0. And then the last section here, we know that 4 comes after 3 and then 5, so on and so forth. So we'll pick one of those numbers, and for convenience, again, let's use x equals 4. Okay. Now, the next thing we do is plug in these numbers into the function. So make x equal to -6 and find out what is the sign of each factor. And then we determine what is the sign of f of x when x is -6. So when x is -6, this becomes -6 minus 3, and that's going to give us a negative number. So I'll put negative here. Now, second factor, when x is -6, -6 plus 2, I have more negatives than positives. That's going to give me a negative number. And then again, we put -6 into x, -6 plus 5. I have more negatives than positive, so that factor is going to be negative. So now we will multiply them. Negative times negative is positive, times negative is negative. So this tells us that f of x is negative. And because f of x is negative, then we say that f of x is below the x-axis. All right, let's move on to this next interval. So from -5 to 2, we're going to use x equals -3. We plug in -3 into x. So -3 minus 3, well, that's going to give me negative. -3, we plug into x plus 2. So -3 plus 2. I have more negatives than positives, so that's going to be negative. Now, -3 plus 5 is going to be positive because you have more positives than negatives. Okay, so now these are the signs of the three factors when x is -3. So we determine the product, the sign of the product. So negative times negative is positive, times positive is positive. So here we say that f of x is positive. Therefore, f of x is above the x-axis. So we'll just write here above the x-axis. So what we're doing here is we're trying to describe the graph of the function in each interval. Okay, so now let's move on to this one, this interval, -2 to 3. So -2 to 3, we're going to use x equals 0. So we plug in 0 to x. So 0 minus 3 is negative. So we're going to have here negative. And then 0 plus 2, that's going to be positive. And then 0 plus 5, that's going to be positive. So now we'll have negative times positive is negative, times positive is also negative. So f of x is negative. Therefore, f of x is below the x-axis in this section or in this interval. Okay, now we plug in 4 into x. So 4 minus 3 is positive. 4 plus 2 is positive. So if we plug in 4 to x plus 5, it's going to be 4 plus 5, and it's going to be positive. So therefore, positive times positive is positive, times positive is positive. So f of x here is positive. And therefore above the x-axis. Okay, now we are ready to sketch the graph. So, okay, let's make a nice coordinate system here. Okay, okay, y-intercept is -30, so it's okay to put the x-axis right here. And, okay, this is a little better. This is the y. This is the x. Okay, so we need to put the scale. So I have here 1, 2, 3, 4, 5. So -1, -2, -3, -4, -5. Okay, now because the y-intercept is like -30, such a big number, we count by ones, it's gonna be too long. So let's count by tens here on the y. So 10, 20. Now for the negatives, I'm going to have here -10, -20, and then -30. Okay, so now we can put our x-intercepts first, which are 3, 0, -2, 0, and 5, 0. So 3, 0 right here, -5, 0, and -2, 0. Okay, now the y-intercept is at 0, -30. Let me graph that. So now we can connect the points, but we know that in this section on the left side of -5, which is right here, the graph is below the x-axis. So that means the graph is found below the x-axis. So we're starting here. So what we're going to do is make a smooth curve going through the points, but it says in this section, f of x is below the x-axis, so it's below. We're going to, okay, now it is going through that x-intercept. Now, what happens from -5 to -2? It says here that f of x is above the x-axis. So that means that the graph will cross the x-axis and go to the positive territory. But then it needs to come down and touch the next x-intercept. So it will reach a highest point somewhere. We are not sure where it is, but between -5 and -2, it will reach a highest point and then go down. It has to go through, okay, it's kind of hard to do this, the x-intercept. And then after -2, on the right side of -2, the graph is below the x-axis, so it will cross the x-axis. It has to go to the negative territory. Yes. Now notice that we're getting closer to the y-axis, so therefore it's going to touch the y-intercept before it goes up and to go to the next x-intercept 3. All right, now we need to find out what the graph does after 3. And after 3, it says that the graph should be above the y-axis, the x-axis. So the graph will cross the x-axis and stay up here. This is the shape of the graph.